The world of computing has undergone remarkable transformations since its inception. From the bulky, vacuum tube-based behemoths of the first generation to the transistor-powered machines of the second, each era has brought about significant leaps in processing power and capabilities. Today, we stand on the cusp of another revolution, the age of third-generation computers, powered by the enigmatic principles of quantum mechanics. Unlike their classical counterparts, which rely on bits to represent information as zeros or ones, quantum computers harness the power of qubits. These quantum bits leverage the principles of superposition and entanglement, allowing them to exist in multiple states simultaneously. This fundamental difference unlocks unprecedented computational power, enabling us to tackle problems that were once deemed impossible for even the most advanced classical computers. The advent of quantum computing marks a paradigm shift in our technological capabilities. This revolution extends far beyond mere incremental improvements in processing speed. It represents a fundamental reimagining of what computers can achieve, opening up a world of possibilities across countless industries. At the heart of this quantum revolution lies the qubit, the fundamental building block of quantum computers. Unlike classical bits, which are limited to a single state of 0 or 1, qubits can exist in a superposition, simultaneously representing both 0 and 1. This unique property arises from the principles of quantum mechanics, which govern the behavior of particles at the atomic and subatomic levels. Imagine a coin spinning in the air, yet to land on heads or tails. This state of uncertainty, where both possibilities coexist, represents the essence of superposition. Qubits, like spinning coins, can exist in this indeterminate state, allowing them to perform computations in parallel. Furthermore, qubits can be entangled, creating a profound link between their states. When two qubits are entangled, the measurement of one instantly influences the state of the other, regardless of the distance separating them. This interconnectedness amplifies the computational power of quantum computers exponentially, allowing them to tackle complex problems with unprecedented speed. In the global race for quantum supremacy, China has emerged as a formidable contender, showcasing its technological prowess with the launch of the Wukong quantum computer. Unveiled in 2024, Wukong represents a significant milestone in China's quantum computing journey, demonstrating its commitment to advancing this transformative technology. Equipped with a 72-qubit Wukong superconducting chip, this third-generation quantum computer has already demonstrated its exceptional capabilities. Since its operational debut in January 2024, Wukong has diligently executed over 339,000 quantum computing tasks across diverse fields, including finance and biomedicine. Wukong's impact extends far beyond China's borders, with over 20 million remote visits from 139 countries and regions. This quantum powerhouse has garnered significant international attention. This global interest underscores the widespread recognition of Wukong's potential to revolutionize various industries and drive innovation on a global scale. China's pursuit of quantum excellence continues with the Tianyan 504, a superconducting quantum computer that pushes the boundaries of computational power. Launched in December 2024, Tianyan 504 boasts an impressive 504-qubit Xiaohong chip, solidifying China's position at the forefront of quantum computing development. This remarkable achievement marks a significant leap forward in qubit count, surpassing the 500 qubit threshold and aligning with international standards in qubit lifetime and readout fidelity. The integration of Tianyan 504 into China Telecom's Tianyan Quantum Computing Cloud Platform further amplifies its accessibility and potential impact. The Tianyan Quantum Computing Cloud Platform, launched in November 2023, has already witnessed over 12 million visits from users in over 50 countries. This global engagement underscores the growing demand for access to advanced quantum computing resources and highlights the collaborative spirit driving innovation in this field. Section 5. Transforming Finance, Quantum Computing, and the Future of Investment. The financial industry stands on the brink of a quantum revolution as third-generation computers promise to transform traditional approaches to investment, risk management, and fraud detection. Quantum algorithms, specifically designed to leverage the unique capabilities of qubits, offer the potential to revolutionize how we analyze financial data and make critical decisions. One area where quantum computing is poised to make a significant impact is portfolio optimization. Traditional algorithms often struggle to navigate the complexities of a vast and interconnected financial market. Quantum computers, on the other hand, can analyze massive data sets with unparalleled speed and precision, identifying optimal investment strategies that maximize returns while minimizing risks. Furthermore, quantum computing can enhance fraud detection mechanisms, identifying suspicious patterns and anomalies that might escape even the most sophisticated classical algorithms. By analyzing transactional data in real time, quantum-powered systems can flag potentially fraudulent activities, mitigating financial losses and bolstering security measures. Section 6. A new era for biomedicine. Quantum simulations for drug discovery. The development of new drugs and therapies is a complex and time-consuming process, often requiring years of research and experimentation. Quantum computing has the potential to significantly accelerate this process, enabling scientists to simulate molecular interactions with unprecedented accuracy and speed. Traditional methods for simulating molecular behavior often rely on approximations and simplifications, limiting their predictive power. Quantum computers, however, can leverage the principles of quantum mechanics to simulate these interactions at a fundamental level, providing invaluable insights into the behavior of molecules and their potential therapeutic effects. This capability has profound implications for drug discovery, allowing researchers to identify promising drug candidates and predict their efficacy with greater certainty. By accelerating the drug development pipeline, quantum computing can potentially lead to the discovery of new treatments for diseases that have long plagued humanity. Section 7. A global phenomenon. International collaboration in the quantum age. The pursuit of quantum advancement transcends national borders, fostering a spirit of international collaboration and knowledge sharing. The development of third-generation computers requires a collective effort with researchers and institutions from around the world contributing their expertise to overcome technical challenges and push the boundaries of this transformative technology. The success of projects like Wukong and Tianyan 504 highlights the importance of international engagement in the quantum realm. With remote access capabilities and cloud-based platforms, these quantum powerhouses have attracted users from diverse countries, facilitating collaboration and accelerating the pace of discovery. This collaborative spirit is essential for addressing the ethical considerations and potential risks associated with quantum computing. As this technology matures, it is crucial to establish international standards and guidelines to ensure its responsible development and deployment, preventing misuse and maximizing its benefits for humanity. Section 8. 6G and beyond. Quantum computing's role in shaping the future. The emergence of quantum computing coincides with the development of other transformative technologies, such as 6G communications. This convergence of innovations has the potential to reshape our world, creating unprecedented opportunities for connectivity, data processing, and automation. 6G networks, with their ultra-fast speeds and ultra-low latency, will generate massive amounts of data, far exceeding the capabilities of even the most advanced classical computing systems. Quantum computing, with its ability to process and analyze vast data sets with unparalleled speed, will be crucial for unlocking the full potential of 6G and beyond. Furthermore, quantum computing can enhance the security and reliability of 6G networks, safeguarding sensitive data from cyber threats. Quantum cryptography, which leverages the principles of quantum mechanics to create unbreakable encryption keys, can protect critical infrastructure and ensure the integrity of data transmission in a hyper-connected world. Section 9. Conclusion. A quantum future awaits. The advent of third-generation computers marks a pivotal moment in human history, ushering in an era of unprecedented computational power and technological advancement. Quantum computing, with its ability to tackle problems that were once deemed insurmountable, has the potential to revolutionize countless industries, from finance and biomedicine to material science and artificial intelligence. As we delve deeper into the quantum realm, we unlock new possibilities for innovation and discovery. The journey ahead is filled with challenges, but the potential rewards are immeasurable. By embracing the transformative power of quantum computing and fostering a spirit of global collaboration, we can shape a future where technology empowers us to address humanity's greatest challenges and unlock a new era of prosperity and progress.